Welcome to the deep dive. Okay, so if you've been, anywhere near a news feed or even just talking to people lately, artificial intelligence, machine learning, it's
Mhm.
just everywhere.
Oh, absolutely. It's kinda hard to miss.
Right. From tools like ChatGPT that just blow your mind to all the latest research breakthroughs, it feels like everyone's talking about it.
It really does.
Hmm.
And I think for a lot of people, it can feel a bit overwhelming,
Hmm.
the speed of it all. How do you even start to, get a handle on this field?
Exactly. And that's precisely our mission for this deep dive. We found this really interesting source. It's a YouTube transcript, actually.
Oh, okay.
Yeah, from an expert who just lays out this super clear, actionable roadmap. For anyone looking to get into AI and machine learning or maybe level up if they're already in it.
Nice. So, like a practical guide.
Totally. Our goal is to pull out the most practical, sort of no fluff insights from this guide. Give you listening a bit of a shortcut, really, to understanding how to navigate this whole exciting, maybe slightly crazy field.
Okay, sounds good. So what are we covering then?
Right. So we'll dig into why machine learning is so important right now. We'll also tackle that big question, the fear about AI and
Ah,
jobs.
yes, the will robots take my job
Well,
question.
that's the one. And then the main part, a step-by-step learning path. We're talking specific programming languages, the math you actually need, which libraries to focus on,
Okay.
and even a couple of books the source calls like revolutionary.
Ooh, revolutionary. High praise.
Okay, let's jump in. So our source really kicks things off by stressing this, well, unstoppable rise of AI and ML, and specifically that machine learning is the foundation, the bedrock for basically all the AI tools we use every day.
Yeah, that's a key point. And the numbers they share are pretty staggering. The ML market itself grew, 17% in 2024 alone?
Mm-hmm.
And the projection is a 34% growth rate over the next 10 years. That's huge. It's not just steady growth, it's like exponential.
It really paints a picture of an industry just exploding, right?
Yeah.
Integrating into everything.
Absolutely. And interestingly, the source makes this specific projection about India.
Oh, yeah. What's that?
They reckon India is really poised to become a global machine learning powerhouse within the next decade.
Wow. Okay, that's a big statement. What does that mean beyond just, job numbers?
Well, I think it underlines why the source calls data science and machine learning the most important, most profitable skills right now. It's not just about today's jobs. It's about this massive wave of future opportunity coming.
Right. It's like a signal flare for where the future is heading, career-wise.
Exactly. Makes it a pretty powerful skill to have in your toolkit.
And with that demand comes the money, presumably. The transcript mentions average salaries in India 7 to 14 lakhs per year.
Yeah, but they're quick to say that's just an average starting point almost,
Right. They imply that if you really master this stuff, you can earn way beyond this.
which makes sense. If the demand is that high, top talent will command top dollar. It's almost like the market's yelling, we need people who get this.
Yeah, exactly. And it's not just about getting a job, is it? The source also points out the potential to, start your own thing.
Mhm. Build a business. If you can leverage AI or ML to create something really impactful that people actually use, well, that's a whole different level of opportunity.
So it's creation, not just employment. And apparently even President Murmu has talked about AI and ML advancements.
Yeah, getting that high-level official recognition really underscores its importance, doesn't it?
Definitely. Okay, so let's pivot to that big worry. The elephant in the room,
Hmm.
AI taking jobs.
Right. It comes up in every single conversation about AI, pretty much.
It does, and it's a legitimate concern for a lot of people.
It is. But the source offers a really interesting counterpoint. Their take is
Yeah.
basically, if you know AI, if you can use it, your job is actually safer.
So it's not AI replacing you, but someone using AI replacing you if you don't adapt?
Exactly. They quote the NVIDIA CEO, Jensen Huang, who said something very similar. You will not be replaced by AI, you will be replaced by someone using an AI.
That really shifts the perspective, doesn't it? It puts the human back in the driver's seat, leveraging the tool.
Precisely. The demand isn't going away, it's shifting. The future needs people who can work with AI, not people who are made obsolete by it.
So data science, machine learning, AI, these skills are already hot, and they're just going to get hotter.
That's the message. It's about investing in yourself for what's coming.
Okay, so the opportunity's there, the demand's there, but how do you actually get started? That often leads to the question, do I need a fancy degree?
Ah, the degree question, yeah.
The source says, well, a basic degree, maybe maths, maybe computer science, it can help. It's not unhelpful.
Sure. But their main point, and it's a strong one, is you don't need to be from some top-tier college or even have a CS degree to really make waves in AI.
That's quite empowering, actually. It challenges that traditional path.
It really does. It puts the focus squarely on skills, on what you can do.
And the person behind the source, they actually have the credentials, right? IIT Kharagpur, silver medalist?
Yeah, they mentioned that. But interestingly, they use it not to say, look how smart I am, but more to say, look, even with this background, I'm telling you, skills matter most.
That's a powerful message. It's like, don't let the lack of a specific degree hold you back. If you can build the skills, focus on the practical stuff.
Exactly. Focus on what you can build and demonstrate.
Okay, so if skills are king, where do you begin? The source lays out this step-by-step roadmap. Step 1, the programming language. And it seems like there's one clear winner.
Oh yeah, Python. Overwhelmingly Python. Like 90% of experts recommend it.
And why is that? Just because it's popular?
Well, popularity helps, but it's mainly because almost all the essential machine learning libraries, think TensorFlow, PyTorch, Keras, they're built for Python. It's the ecosystem.
Gotcha. So the tools you need are mostly in Python.
Exactly. And beyond libraries, look at the actual code bases out there.
Yeah.
Image generation, video generation, even the core stuff behind models like ChatGPT. A huge chunk of it is Python.
And is it hard to learn? For someone starting out?
That's the other advantage. Python is generally considered, relatively easy to pick up compared to some other languages. The syntax is cleaner.
So you can get up and running faster, focus on the ML concepts rather than fighting the language itself.
Pretty much, yeah. It lowers the barrier to entry.
Okay, so Python's the foundation. What's step 2 on this roadmap?
Right. Step 2, and this is critical, mastering data manipulation, specifically with 2 libraries, NumPy and Pandas.
NumPy and Pandas, why are they so important?
Because machine learning is all about data. Before you can feed data into any algorithm, you usually need to clean it, reshape it, prepare it. NumPy and Pandas are the tools for that job. They're foundational.
Okay. So NumPy first. What do you need to know there?
For NumPy, the advice is to get the basics of ND arrays, that's like multidimensional lists for numbers. Understand things like shape, flattening arrays. It's about efficient number crunching.
Right, the building blocks for handling numerical data efficiently.
Exactly. The source suggests the NumPy Quick Start Guide on their website, but warns against getting totally lost in the weeds initially. Learn the core ideas.
Don't boil the ocean, basically.
Precisely. But then Pandas, that's different.
Ooh, how so?
The source really stresses learning Pandas in detail. Reading data files like CSVs, manipulating these things called data frames. They warn that just skimming Pandas will limit you. You'll end up being a, quote, small-level ML engineer.
Okay, so Pandas requires a deeper dive. Any recommendations for learning it?
Yeah, they mentioned 10 minutes to Pandas from the official Pandas documentation. It's a good starting point for self-learners, get you hands-on quickly.
And they mentioned a common mistake here too, right?
Yes, a big one. People get excited and jump straight to the machine learning libraries, like scikit-learn.
Without really getting NumPy and Pandas first.
Exactly. And then they hit a wall because everything in ML uses these data structures, arrays, data frames, and they don't understand how to work with them. It leads to a lot of frustration.
Okay, so Python, then really nail NumPy and Pandas. Got it. What's step 3?
Step 3 is the math foundation. You can't really escape it entirely.
Uh-oh. How much math are we talking?
Well, the basics. Basic algebra, probability, statistics. Nothing too crazy initially. For linear algebra, they recommend some notes from Queen Mary University.
Okay.
But with a big caveat, don't spend like a whole year just studying linear algebra theory.
Phew. Okay, so learn it as you need it.
Kind of, yeah.
Yeah.
Learn the concepts when you actually encounter them in an algorithm or a project. Make it practical.
That makes sense. What about probability and stats?
They highly recommend a book called Hogg's Book by William Hogg.
Hogg's book. Okay. Read it cover to cover.
No, again, strategic use.
Yeah.
Keep it on your desk. Use it as a reference when you're working on something and need to understand a specific statistical concept or probability distribution. It's a workflow companion, not a textbook to memorize.
I like that approach. More practical. Okay, so math foundation covered. What's step 4?
Step 4 is finally diving into the actual machine learning algorithms.
All right. The exciting part. Where do you start?
The advice is to start with the scikit-learn library. It's kind of the workhorse for traditional ML. Learn the basics there, like linear regression, gradient descent.
Gradient descent. That's how the models learn, right? Adjusting things to get better predictions.
Exactly. It's a core concept. And crucially, The source emphasizes project-based learning here.
Ah, so don't just read about algorithms, actually use them.
Yes. Apply supervised learning algorithms, that's where you have labeled data, to a real project. They use a house price prediction project as an example in their course. Build something end-to-end.
And scikit-learn is the main tool for that.
For a lot of standard ML tasks, absolutely. The source calls it the go-to library for machine learning.
Okay. What about after supervised learning?
Then move on to unsupervised learning, finding patterns in data without labels, things like clustering. They recommend another book, Mining of Massive Data Sets, for theory, and again, learning how to apply clustering using scikit-learn.
Got it. So it's a gradual progression, building complexity, always applying it.
That's the idea. Learn, then do. Repeat.
Now, you mentioned earlier the source highlights a couple of revolutionary books. Let's talk about those. What are they?
Right, the game changers. The first one is called Hands-on Machine Learning with Scikit-learn and TensorFlow.
Okay, that title covers a lot.
It does. And the source describes this book as potentially changing your ML journey forever. High stakes.
Wow. What makes it so special?
Well, first, the author is an ex-Googler from their research team, so there's real-world credibility there.
Okay, good start.
And the book itself is described as super in-depth, very detailed, but packs with Python code. It apparently covers the fundamentals, what is machine learning in Chapter 1, then jumps right into an end-to-end project in Chapter 2.
So it gets practical really fast.
Exactly. And it covers the math behind the algorithms too. But the key thing seems to be the style. They say it's written in fun language, less bookish than typical textbooks.
That can make a huge difference in learning something complex.
Totally. So the recommendation is strong. One of the best books for machine learning. A must-have copy.
Okay, hands-on machine learning. What's the second book?
The second one is Python for Data Analysis by Wes McKinney.
Wes McKinney, didn't he create pandas?
He did. So this book is apparently amazing for really learning pandas effectively, straight from the source, so to speak.
Makes sense. Learn pandas from the guy who invented it.
Right. And crucially, the advice for absolute beginners is actually to start with this book, the Pandas book.
Before the hands-on machine learning one?
Yes. Get your data manipulation skills solid with McKinney's book first, then move on to the broader ML concepts and hands-on book.
That's really useful sequencing advice. Avoid that frustration we talked about earlier.
Exactly. And the general advice for both books holds. Don't feel pressured to read them cover to cover right away, especially if time is tight.
Right. Use them as references, build knowledge gradually.
Acquire a good amount of knowledge. Dip in and out as needed. Make them part of your toolkit.
Okay, so we have the roadmap, the tools, the key books. What else? The source mentioned projects are key.
Massively key. They really hammer this point. Building more projects leads to a better grasp of machine learning. It moves from theory to intuition.
Makes sense. Practice makes perfect.
And beyond just building your own projects, they encourage actively engaging with the latest research, the breakthroughs you read about.
How do you do that? Just read the papers.
Reading helps, but they suggest going further. Check GitHub. Often, the code and model architectures for new papers are shared there.
Ah, so you can actually see the code behind the breakthrough.
And not just see it, run it. Try running the models on your own computer.
Even if it takes ages.
Even if it takes ages. Or use tools like Google Colab. It's like an online coding notebook, often with access to more computing power.
Okay, so you can experiment even without a supercomputer at home.
Right. And they even suggest installing apps like Llama to run some of the open source large language models, the tech behind ChatGPT, locally on your own PC.
Really? You can run those locally.
Some of the smaller or optimized ones, yeah. The point isn't necessarily to get cutting-edge performance, but to get a feel for the technology.
Why does that feel so important?
It builds confidence. It builds motivation. When you actually run an image model, even if it takes an hour on your laptop to make one picture, you've done it. You've interacted with this powerful tech directly.
It makes it real, not just abstract.
Exactly. That hands-on experience, that confidence boost, is invaluable for sticking with the ML journey, which can definitely be challenging.
Okay, wow. That's a really comprehensive roadmap, from Python basics all the way to running cutting-edge models yourself.
It really is. Very structured, very actionable, less about vague ideas, more about do this than do this.
So wrapping this up, we've unpacked this expert guide, this roadmap for diving into machine learning. It feels very practical.
Definitely. And the source ends with this really strong conviction, sort of a final piece of encouragement.
What's that?
They basically say that starting data science and machine learning today is going to be one of the best decisions of your life.
Wow, strong words.
Yeah. And that it will pay you a lot in the future. Really
Yep.
a big bet on the importance of these skills.
So it really brings us back to that potential we talked about at the start.
It does.
All right, so here's maybe a final thought for you, the listener, to chew on. We've just laid out this clear path, shown how accessible these incredibly powerful tools are becoming.
Mm-hmm.
So putting that together, what surprising problem, maybe something in your own community or industry, could you tackle using AI or ML? Or what kind of, groundbreaking business idea might you be able to build now that these tools are within reach?
Yeah. What could you create? The possibility